Hello, everybody, and welcome to lesson 2 of this week, week 5 of our online learning, Dilations in the Coordinate Plane. So back in Unit 2, you talked about transformations, translations, rotations, and reflections. The other one that goes along with that is called a dilation. It maintains the shape of a figure, but it either makes it larger or smaller. It's stretched from a particular point. That point's called the center of dilation. So we are going to be either enlarging or making smaller our shapes. So if I look at this first figure, we're going to dilate this quadrilateral ABCD from the origin by a factor of 3 to form our new shape A prime, B prime, C prime, D prime. And how we're going to do that is we look for what our dilation factor is. And if I look, I see, again, I want to dilate by a factor of 3 from the origin. So what we're going to do is we're going to take each of these values, A, find our A prime, we're going to multiply our original point 3, 2 by 3. And when we do that, we get our A prime value of 9, 6. So if I were to plot the new point, I would go over 9, up 6 to find A prime. We're going to do the same thing with the rest of the points. To find B prime, we'll multiply 3 times the point negative 1, 2, and we get negative 3, 6. So B will be at negative 3, 6. For C prime, we multiply 3 times the point negative 2, negative 2 to get C prime at negative 6, negative 6. So left 6 and down 6 for C prime. And then the last point, D, multiply D by 3 in order to get D prime at 3, negative 6. And if we connect those points, we see that we just dilated our original quadrilateral ABCD by a factor of 3. So this was an example of an enlargement. If I look at my next example, we'll see that my shape is actually going to get smaller. I have a figure ABCDE formed with the following points, and I am going to dilate it by a factor of 1/2. If I see that fraction there, I know that my shape is going to get smaller. So the first thing I'm going to do is mark all of my points. A is at negative 4, negative 2. B is at 6, negative 2. C is at 6, 4. D is at 0, 6. And E is at 0, 4. So what we're going to do in order to find our new values is we're going to multiply each of these by 1/2. So you can either do that by turning it into a fraction or keeping it a fraction or turning it into a decimal. So if I multiply 1/2 times negative 4, negative 2, I will get, well, half of negative 4 is negative 2, and half of negative 2 is negative 1. So A prime will be here at negative 2, negative 1. Again, we can keep it as a fraction if we wanted to. Take half of 6, which is 3, and half of negative 2, whoops, is negative 1. So we'll go over 3 and down 1 to get B prime. C prime, take half of 6 and 4. Half of 6 is 3, half of 4 is 2. So C would be at 3, 2. C prime, I should say. D prime. Again, you can use the decimal or the fraction, it doesn't matter which one. Half of 0 is still 0. Half of 6 is 3. 0, 3. D prime would be here. And then the last one, half of 0 and 4. Half of 0 is just 0, and half of 4 is 2. So 0, 2 would be E prime. And there we go. I've got my shape scaled down by a factor of 1/2. Again, dilations can get larger or they can get smaller. The other part of this lesson is being able to determine the scale factor from a point to your triangles or to your figures. So what we're going to do is we're going to determine the scale factor from point D of triangle ABC to our dilated triangle of A prime, B prime, C prime. So what we're going to do first is we're going to compare the distances between 2 points. Since this is a dilation, I know that the distance from D to B will be similar to the distance from D to B prime. And I can see those points. D is at -4, -2, and B is at -4, 0. So the distance from D to B is 2. I can look at the next shape as well. I want to find the distance from D to B prime. Again, D is at -4, -2. B prime is at -4, 6. The distance from -2 to 6 is 8. I want to compare those factors. I want to find a relationship to get from the small triangle to the large triangle. Since I know I'm dilating from the small triangle to the large triangle, my dilation factor will have to be bigger than 1. Because remember, if we look back, the factor here was 3 when my shape got bigger. It was 1/2 when my number got smaller, when my figure got smaller. So in order to get larger, I want a whole number and not a fraction. So if I'm looking here, the relationship between DB and DB prime is 2 to 8. So in order to find that scale factor, I am just going to take that 8 divided by 2 to get 4/1. Again, I put that larger number on top because I want my scale factor to be a whole number, not a fraction. When I do that, I see that my dilation factor or scale factor is 4. So just to recap, because I'm dilating from point D, and since D and both B's, B and B prime, are on the same line, I find that the easiest way to find a distance. Because from D to B, I go up 2. From D to B prime, I go up 8. So again, you take your larger number, divide it by your smaller number of those distances to find your scale factor. And that's our lesson for this week. I hope you guys learned a lot about dilations and the coordinate plane. Again, be sure to ask your teacher if you have any further questions. And I'll see you all next week.